In this video, we will perform a hypothesis test for the difference of two proportions. So again, we're dealing with the same thing that we did in our last video. Instead of a confidence interval, we're doing a hypothesis test. The biggest thing that is different between the way that we've done hypothesis tests in the past is that our assumption is that the two proportions, or when we get to means, the two means, are going to be equal. So my null hypothesis should pretty much always look like this, unless in the question it says we assume the difference between something is 3, in which case I would replace that 0 with a 3. But I would say like 97% of the time, especially in an intro stats class, this is going to look just like this. P1 minus P2 equals 0. Now keep in mind, you're going to change these values up so that we know which one you have first and which one you have second. The alternative hypothesis is any of the same thing that we had before. But again, keep in mind that what we're saying here is that we're assuming that if I take the first proportion minus the second proportion, that result will be 0. Now, if you see in my stat lab it look like this instead, that's the same thing. This is saying that the two are equal, and this is saying the two are equal because when I subtract them I get 0. I tend to use this format, and that's the format I would like you to use. So here's a great question. Would being part of a support group that meets regularly help people who are wearing a nicotine patch actually quit smoking? So Douglas County, which is here in Omaha, Nebraska, runs this experiment and randomly divides the subject into two groups. They give the number of people in each group and the percent in each group. Now, we've already checked conditions, so I'm not going to do that again. You can refer to the previous video. But we are going to perform a two proportion z-test. Now, keep in mind, we've already done this question with a 90% interval, and this was the interval that we got. Now, my hypothesis was that P1 minus P2 is going to equal 0, and I want you to notice that 0 is not in that interval. So if I made a number line, 0 would be here, 0.036 would be to the right, and 0.204, so this is all to the right, 0 is below. Therefore 0 is not within that interval, and so I know that I'm going to reject the null, but I'm going to go ahead and do the test to make sure. Keep in mind here, just like we really stressed last week, we're wanting to keep the same level of confidence, and in this case we would find 100 minus C, which was our 90%. So 100 minus 90 is 10. Divide that in half, we get 5%, so our alpha level is 5%. We divided by 2 since our test will be one-tailed. So how do we know it's one-tailed? Because when we write our hypothesis, it's going to be going in one direction. So let's take a look. Hypotheses, again, the null hypothesis, P1 minus P2 equals 0. Don't forget to write it in words. There's no difference in quit rate between those attending meetings and those who don't. Now the question said, would being part of a support group help people who are wearing the nicotine patch actually quit smoking? So our assumption is that this is going to be true, so that when we write this alternative hypothesis, we're saying yes, it's going to actually help people, and so the people who are attending the group will quit more often, and therefore that's these guys. So now the calculations, of course, we are going to use StatCrunch to do all of it, just as we did before. Again, we're using that 45.76 and the 30.2, so we're using decimals on this one, just as we did before. Notice here I have a p-value of 0.0094. Also note that it does give me my z-score. It does give me my standard error. It does give me those values that I entered in. So if you're in a MyStatLab question that's asking for those values, please don't waste your time and try to figure out how to do this by hand. Not that it's not, a great little exercise for you, but that's not our focus this week. So again, our conclusion, since 0.00939 is less than the alpha level of 0.05, we reject the null hypothesis. There's evidence to support that people quit smoking at a higher rate with a support group than those who don't. Now keep in mind we did have that 90% interval, so I'm going to add that to my conclusion. I'm 90% confident that between 3.6% and 20.4% more smokers, because there was a positive interval, will quit smoking by attending a weekly meeting than smokers who don't attend a meeting. Now, does that support my decision? Yes, because 0 is not in my interval. Here's a question for you to try on your own, so feel free to press pause, find the hypothesis test, be sure to write the appropriate hypotheses, and then press play to check your work. So here's our question, and again, I should be writing my hypotheses. This one asked, is there a gender gap? So there's no direction that is specified within the context of this question. So notice my hypothesis is equal to and not equal to. I've written them both in words. There is no difference or there is a difference. The calculations, again, I'm back over here. Stat, proportion stats to sample with summary. I'm entering in those same numbers I did before, which I'm not going to do for the sake of time. But remember, use the decimals. If you don't use the decimals, you're not going to get the correct solution. So to give you a closer look, here I end up with a p-value that it says less than 0.0001, which means it's essentially 0. Now, for my conclusion, I need to know what my alpha level is. So I had a 95% interval and a two-tailed test. So in this case, my alpha level was actually 2.5%. Make sure you're including that. Since our p-value is essentially 0, we reject the null hypothesis. There's evidence to support that the proportion of men who believe men are smarter is greater than the proportion of women who believe men are smarter. Now, how do I know that it's greater? Well, because it all depends on who I put first. So I put men first, then women. If you would have done it backwards, your values would have been negative, and then it still, same conclusion, you would just format it in a different way. So I'm 95% confident that between 9.1% and 18.9% more men feel men are more intelligent than women who feel men are more intelligent.